Sharma, along with my colleague Soni Setia, will be our hosts for this plenary talk. We are delighted to welcome you to the 4th Biennial International Conference on Future Learning Aspects of Mechanical Engineering, FLAMES 2024, organized by Department of Mechanical Engineering, ACET, Amity University, Uttar Pradesh, Noida.
Today, we have our guest, Professor Dr. K. Muralidhar sir, to present the talk with us. I request Professor Dr. Basant Singh Sikarwar to kindly felicitate Professor Dr. K. Muralidhar sir. Today, our session chair is Dr. Amrik Dalal, IIT Guwahati. I welcome you, sir.
Let's have a huge round of applause, please. The topic of his talk is thermal techniques for pure water production. Dr. K. Muralidhar is a professor of mechanical engineering at IIT Kanpur, where he has worked since 1987. He has a PhD from University of Delaware and postdoctoral research experience at Lawrence Berkeley Laboratory. He has conducted a wide range of experiments and performed numerical simulation in subjects related to fluid mechanics and heat transfer. Now I request sir to please come upon.
Thank you for I hope the mic is on. I hope they can hear me. Okay. Well, thank you for coming over to this presentation. Thank you. The topic of interest is pure water, essentially potable water. And some related topics would be sustainability, low carbon footprint, specifically decentralized approaches. Talk is sort of generic in nature. It's a survey of the field. Hopefully, I'll cover more of what is happening. Not audible? So, तो वो mic दे देना. Can you hear me now? Okay. Yeah, let me start talking about pure water. Some funding agencies I would like to acknowledge. Quite a few doctoral students. I'm also collaborating with Basant here on this topic. Professor Samir Khandekar was my collaborator for over 10 years. Would like to remember him on this occasion. This talk is sort of a general purpose introduction to the subject. So there are several definitions available. What is pure water? Is something that you can consume over a lifetime and not develop any ailment. That's the WHO definition. Or what we used to say about air, it's colorless, odorless, tasteless. free of bacteria and other potential health risks. Question is, why worry about pure water? It's essential for maintaining public health, quality of life. In turn, it has benefits like reduction in poverty, healthy society will definitely contribute to the economy of the nation. Of course, one can go deep into the definition, the chemical composition of potable water. So these are available. Then when you say I'm producing potable water, then you have to meet these guidelines. Of course, apart from water for drinking, pure water is required in quite a few applications. It's not something that comes to our mind immediately, but thermal power plants, nuclear power plants require ultra pure water. That's the working medium. Of course, condensers, cooling towers, they require a large volume of clean water to reject heat to the environment. Data centers, HPC, supercomputers. So the power consumed by the air conditioning system, for example, the one in IIT Kanpur runs into megawatts. So they also have power generation followed by heat rejection, and a lot of water is consumed. This is clean water. You can't have fouling and things like that. So it is clean water. The question is, where do you get this clean water from? Practically nowhere. It has to be clean. But we have large sources of water, starting from rainwater, groundwater. So since we are based in Kanpur, I thought I would show you this Ganga Barrage. It's a source of drinking water in Kanpur city. Fortunately, it's almost full at the moment. So once you consume that water, what next? So fortunately, we are also blessed with a hydrological cycle where water, mainly from oceans, will evaporate, form clouds, and then condense precipitation. Part of it drains at the surface in the form of rivers. Part of it goes into the ground. So we may pick water from the rivers or lakes or from underground. It's a source of water, but then you have to make it pure so that it is fit for consumption and also fit for industrial use. So while preparing this talk, I decided to consolidate information available in internet sources. So it turns out 97% of water is available present in oceans. Fresh water is only 3%. It's a little bit in the atmosphere, 0.001%. Actually, we are trying to tap every source possible: fresh water, ocean water, and atmospheric water. If you think of 3%, 30% is groundwater, 68% is ice caps and glaciers. The rest is 0.9. If you think of 0.9%, lakes are about 87% of that. Swamps and rivers are about 2%. So if you say there is a water shortage, the most obvious source would be oceans. Why not just use ocean water? So it boils down to the power required to take that water and clean it up. Lakes and rivers contain the least dissolved impurities. So it's obvious that cleaning them would be less expensive than cleaning saline water from oceans. So if you think about freshwater resources, that was 3% of the total. 4% of that is available in India. So, of which 80% is groundwater, 20% is surface water. Okay, so you can see that pure water per se, on a planetary scale, on the global scale, very scarce on one hand. On the other hand, the need for that water is also going up. In our country, population pressure is very real. Higher the pressure, more is water needed for drinking. But you also need more energy. So all these power plants, thermal power plants to nuclear power plants, they are pure water guzzling. On the other hand, we have this erratic variability in weather patterns. So even if it rains, somebody told me, oh, it rained in, what is it, South Delhi, but did not rain in North Delhi, this and that. So obviously Delhi is a tiny place. So there's too much of variability in monsoon. Actually, this data is neatly encapsulated in this water stress map. You will see that blue is great. Canada to Russia to large parts of Latin America, Australia, they're all in a very comfortable zone. India, if you see from down below, it is really red. In between, we have a comfortable patch of yellow, then again it becomes reddish. So India is considered the most, among large countries, it is the most stressed. Middle East is also stressed, but they have money and they can actually buy water. We don't have that option readily. Even though we are drinking bottled water, not everybody can do it. So in addition, we tend to pollute whatever water is available. So groundwater already has dissolved salts, may have some radioactivity, and in addition, they get contaminated by poisonous material. So dissolved impurities like arsenic, of course, have to be eliminated. And in addition, dissolved salts also have to be brought below a certain level for human well-being. We also have this very unique problem in that we deliberately contaminate water bodies. So, and then there is industrial waste, societal waste, everything going into water that is also the source of drinking water for us. So, as much as we may hate it, regulation is definitely a very important step in producing potable, drinkable water for people and for industrial use. Of course, we have all these informal techniques for cleaning water. We use swimming pool in Kanpur. They pour such a huge amount of bleach into it. You can smell the swimming pool. Then we use alum for coagulation of all the tiny particles. Boiling is the ultimate measure, which is okay for a household, but not on the large scales. Very energy intensive. So let me briefly talk about how we can purify water. These methods, by and large, have been developed in the context of oceans, because India has a very long coast. One is, this is on scale, that is for producing lakhs of liters per day for a township. One is reverse osmosis, which is almost 40% of the plants, and flash evaporation, which is 60%. I'm not describing the municipal approaches to water purification, of sending them through sand beds and so on. So both methods produce practically distilled water, and you have to add salts to make them fit for consumption. Both of them require electricity, fairly large amount, which means there is an issue of sustainability, issue of carbon footprint. Both methods produce a large amount of slurry. Generally, we don't realize, but not more than 20% of this total water becomes pure. The rest of it becomes concentrated brine, which is quite harmful, but we dump it back in the ocean, assuming ocean will take care of it. The numbers that are floated around show that the water cost may be, let's say, 1 rupee per liter, which is nothing. But you have to add to it the cost of packaging and then the cost of transportation. So the costs keep going up. So reverse osmosis, you pressurize brine and then across, you use a semi-permeable membrane whose pore size I have mentioned here is a fraction of a nanometer, through which dissolved impurities will not go through. Only pure water will go through when you pressurize. So you can do some calculations. So you use something like 60 to 70 bar pressure difference is required. And if you want, let us say, per person you may need 10 liters of water per day, let us say. Then you multiply by population, multiply this flow rate times pressure drop, will give you the power requirement. From power requirement, you can calculate the cost, which I have just shown could be as little as 10 rupees per person per day. So it's at the prevailing costs of electricity, that cost of water production is nothing. But it becomes tricky when you bring in packaging and transportation. So if your village is remote, then carrying it every day, just making a pipeline or carrying it every day is not cheap. So I think all of us, at least in our campus, all of us have a domestic water purification system. RO is really meant for dissolved impurities. So you have to do some pre-treatment, eliminating biological or bacterial impurities. You have to remove particulates. Only then you can send it to RO. And after that, you have to add some taste to it so that you can drink. So this RO unit, but it's misleading because probably the upper middle class can afford it. And anyway, it depends on continuous availability of continuous source of water, which is not as common in our country. The same principle is adopted on scale, but then you need some energy efficiency measures. So energy recovery systems are required so that form of electricity. In flash evaporation, first of all, you have to depressurize. It's not pressurized. Depressurize and allow for massive rates of evaporation. Then you condense them at a slightly lower temperature. So the brine, the impure water going in is warmed up. So part of the energy input is thermal in origin. Array, light. So when it is thermal, I think we all have a gut feeling that it is less expensive than electrical. Which is part of the reason why flash is more popular than RO. RO requires pressurization, flash requires creating vacuum conditions. There is that issue of having a membrane in RO. Membrane technology is also classified. Not everybody can make it. Make large membranes at the nanopore scale. It's not so simple. There is no such strategic technology required for flash. Typical setup where you have to warm up the impure water. It could be seawater warmed up, and then it evaporates in an evacuated chamber, and then you pass cool water, which is, let's say, at ambient temperature. Ambient is cold here. This heating could be done using solar, or you could be done using waste heat of an industry, or you could use biomass for heating. So it's not electrical heating. That would not be appropriate. And then there is condensation, that you collect pure water separately. And the latent heat can also be reused, because that cold water you sent in will now pick up latent heat. So the cycle is thermally also quite effective. But then you have to pay for creating vacuum conditions and for draining out the distillate. So here there is some amount of indigenization that has happened. We have a research lab by name National Institute of Ocean Technology. They have worked on using resources available in ocean. First, for power generation. So they use the natural temperature gradient available in water. It is warm above, let's say 25 degrees Celsius, and cold below, let's say 5 degrees Celsius. So this 20 degrees Celsius temperature difference can comfortably run an ammonia cycle, Rankine cycle using ammonia, and you can have an electrical output out of it. So as shown on the right hand side, this cold water is available down below. So this cold water line then turns out to be critical technology. So over the depth is shown here as 1,000 meters. In India, it is more like 2,000 meters. 2 kilometers length of cold water line coming from down below. You have to bring it to the surface to condense the ammonia vapors coming out of the turbine. There is an electrical output. That is, then that electrical output can be used to purify water. But NIOT has come up with a hybrid approach where warm water above is evaporated in evacuated chambers, and this cold water is used to condense the vapors. So there is no electricity per se that is, but you still need some small electricity to create vacuum conditions and also to flow both cold water and the chilled water as well as the distillate. All of them require some small electricity. But that is much smaller than what you need for running the entire plant. So they have a schematic where water from the surface of the ocean, they have set up several such prototypes. And they set up one plant in Lakshadweep. And I'm told that the social impact of providing clean water to the people residing, the indigenous people living there, has been remarkable. Their lifespan has actually increased just because pure water is available at a practically throwaway cost. So if you want to produce 1 lakh liters per day, this is from an OTEC plant. Okay, so using warm water above, cold water below. Plant is like a barge floating on the ocean, some 1 or 2 kilometers away from the coast. It will require a power input of only 65 kilowatts. But these are all centralized approaches. Means you have to still store and transport, package, and then transport. So while discussing pure water generation, water savings is often discussed at the same time. So you have to conserve water, don't waste it. Recycle water as much as possible. Rainwater harvesting is becoming quite common. Lake rejuvenation, I think there was a time when apartment complexes were coming up on lake bodies, but now there is better awareness. We're trying to reclaim our lakes and make them into water bodies. Of course, there is a need for massive education. I was told when I visited Singapore, they told me that they import 90% of their, 80% of their water from Malaysia. And they said it is a national policy to reduce 80% to 60% in 5 years. And this policy is taught to students in schools. Everybody is aware of it. So they practice water conservation, recycling, rainwater harvesting, whole lot of methods are practiced. Here is this picture I got of a house with rain harvesting system in Singapore. This picture I got this Ukkadam Lake, Coimbatore, which was a dump, and then it became a lake not due to government intervention. Government, in fact, tried to stop it because they wanted flats. But the citizens' initiative converted that area into a lake. So similarly, many farmers practice drip irrigation to save water. This slide, I will just wanted to say that agriculture is a major consumer of both water and electricity. The farmers don't feel it because almost everything is free for them. We feel it. Try to make this important point as quickly as possible. That if you have a centralized system for water purification, it is of course inexpensive. Space, because it's all compact, space requirement is small, but it produces a huge amount of slurry. So if it is RO, all the electricity, all the power requirement is in the form of electricity, so large carbon footprint, and then you have to establish a water distribution network. So it suggests that we look for decentralized approaches where carbon footprint is smaller, water distribution and storage are not major issues. Many decentralized water purification systems will not produce a slurry, they'll produce solid waste. And solid waste disposal is a lot more effective, doable compared to liquid waste. But decentralized has a major problem in terms of productivity. So the amount of water produced, the rate at which clean water is produced is very small. So that is where all the challenges are, and that is where a substantial amount of research has to be carried out. I'll give you a few examples. I'm told in African countries they have continuous fog formation, particularly in hilly regions around the year. They trap that fog using screens. So we also try to do such experiments in the lab by creating a fog generator. You bubble warm water, air through warm water and cold water, mix the two and you get a fine distribution of water droplets. Then you try to trap them using screen, like in that picture on the side. This is on the lab scale, you'll see water dripping. You collect maybe a few grams per hour. I'm told in MET there is a large activity related to solar stills, where solar energy is used to warm up water, and then you evaporate, and then you condense it on a cooler surface. So the water productivity you can see is something like 2 to 3 liters per meter square per day. Increasing it is a research challenge. So one augmentation technique that I saw in internet, we have a visitor from Chile. This is a picture from Chile, where you have some 304 floating solar desalination chambers, including Fresnel lenses for concentrating solar energy. All the water this is floating on a lake, huge lake. This is a lake created after mining copper from a hill-like region. And that water is then distributed at an elevation, so they have a natural advantage in water is distributed to the neighboring villages. So the augmentation step is just to increase area and concentrate solar radiation. I think in India, they are trying out methods like phase change material so that the solar cell can run even during night time. Make use of thermosiphons, try to use the latent heat that is rejected. So augmentation devices are required so that you can go from 2 to 3 liters per meter square per day, I mentioned, to larger numbers. So Professor Khandekar, my ex-colleague, was working on this idea of interfacial heating. Why heat the entire body of water? Just you do interfacial heating. And then he placed porous material at the interface. And then it was drawing water, essentially by capillary effect. It was drawing water from the impure water body, and then it was evaporating at the top, condensing somewhere else, and you got pure water. So it was a Ministry of Textiles project, because textiles people are now looking at coming up with new types of cloth that can be used for water production. So in this decentralized approach, one essential idea that is proposed is that it should not be an integrated unit. If you try to integrate, performance goes down. So you heat at one point, evaporate somewhere else, condense somewhere else, and you try to maximize the effectiveness of every intermediate step. So another project, the solar heating at the top, and then we use this cloth. I'll just show you an example of cloth that the Ministry of Textiles gave us. And then there is condensation, and then so here we have multiple stages of condensation so that there is reutilization of latent heat. So in non-woven fabric, the pore size tends to be naturally small, capillary forces are high, so a lot of water can be sucked in. So on the right hand side, you will see that pinkish color, that is the water rise, while in the woven fabric, there is hardly any, this is slight brown patch at the bottom, there is hardly any rise of water. So non-woven is the way to go. Then you have to alter the pore size, distribution, pore size, pore shapes, and you can increase the water productivity. And then you may keep the heat source at the top, so water that has gone up gets evaporated. See, from the research perspective, evaporation and condensation with capillarity turns out to be a very important subject. Many of our students are working in this. It's also the theme of my collaboration with Basant. So this atmospheric water generator was made in Basant's lab. Then we took it to IIT Kanpur. So we're testing it, we're trying to see, of course it requires cooling of the wall where condensation can take place. But a lot of original research related to moist air condensation has been carried out by Basant and his students. Those models will help tell us how well these technologies will perform. I should mention here that if you use a bare metallic surface, water condensation is very small, but you have to texture it somehow to produce hydrophobicity, super hydrophobicity, and then a higher amount of condensation rate. Okay, so essentially, maybe I can skip this slide, which says you can texture membranes selectively so that you can remove elements like arsenic alone can be removed, methylene blue, that means hydrocarbons alone are removed. So that is possible by suitable texturing of the membrane, the pores of the membrane. Okay, so I think I have given a kind of a bird's eye view that we need a large quantity of clean water. Of course, we need a large quantity of potable water, but for industrial use also we need a lot of clean water. Of course, you can always say, let's conserve water. It's not always pragmatic. We can do water purification on scale, but it is, as of today, it is inexpensive, but it most likely to become very expensive. So thermal techniques play an important role because compared to electrical, thermal is much cheaper and also available, readily available. Most of these thermal techniques will use this evaporation condensation route with an influence of capillarity. So these steps, evaporation, condensation, happen on metallic surfaces, on surfaces in general. So the nature of the surface plays an important role. That's from a research perspective. But if you want to develop technology rapidly, then if every new idea you have to make a prototype, test it out and see what is happening. So somebody was asking, how do we make products? You have to build them over and over again. It's the incremental improvement. At some point, there could be a major leap. Otherwise, you have a new idea, you have to test it out as quickly as possible. So, thanks a lot for your attention.
Sir, for enlightening us on the topic water purification. So, in the interest of time, just we'll take one or two questions. Any questions?
Is it good enough for our health? Because it's not having minerals. They all been taken away by the membrane.
Yeah, I covered RO at some length. RO is the, I think 40% of the purification plants are RO. 60% are flash evaporation techniques, the thermal techniques. So RO is very inexpensive, but it is centralized. So after you make it, you still have to package it and you still have to.
No, sir, I'm not referring to the industrial.
Domestic RO.
RO water for
domestic RO, you need those pre-processing steps. You have to eliminate bacteria, you have to eliminate suspended impurities. Then you do RO. Then you have to add something to bring some flavor into it. So we have these
only flavors, sir. What about those minerals which have been taken away now?
Right. So there is a setting for TDS, right? So if you are not comfortable with, let's say, I don't know the scale, but something like 10, I think goes up to 100 probably. If you set it at 10, you will hardly have any minerals in it. So they recommend that you keep it at 20 or 25. So deliberately underperform so that you have some minerals. For that, you need to know what the minerals are in groundwater. So in our campus, we know it is calcium, magnesium, potassium, and so on. And we have been advised to keep the TDS, total dissolved solids level, at about 25, because your body still needs some.
No, sir, I'm talking about a common man. I have RO in my house, and what comes out from the RO is, as far as I feel, it is void of minerals. So what do I do? I mean, it's not that.
No, you have to reduce the TDS setting in that RO unit. You have to call the person and reduce the setting so there is less of minerals coming out.
Thank you, sir.
Yeah.
Dr. Chatterjee. Next.
Well, actually, my question is on the same line. That there is the TDS means it should be. I think somewhere I have read it should be close to 100, as you said. But sometimes in many places we do not need actually the RO system because the TDS is not so much alarming. So unnecessarily, by using the RO system, we are reducing the TDS, actually the useful mineral. So that is a major concern, and the commercial water purification companies are making us fool by supplying this RO system actually. So that is one concern.
I agree with you. Between groundwater and RO, groundwater or well water is okay. But if you go to a place like West Bengal where you have arsenic in water, you need to remove that arsenic.
Yeah. In some places, if the TDS, if TDS is more than 300, 400,
has become popular.
Yeah.
When your source is ocean.
Right.
Okay, when you are on the coastal area, you say too much of water, why can I not use it? So then you have to do RO because that salt content is massive.
Yeah.
So RO has become popular in that context.
And the second,
it's an overkill, I agree. You are dependent on groundwater, you may not need RO at all.
Right, right.
Unless somebody has found
Unless the
some-
TDS is very alarming.
you have this arsenic kind of
Right, right.
dissolved impurities.
But this commercial purification system, that they are not capable of reducing the arsenic, removing arsenic.
Okay, so
Yeah,
that
these are not capable.
Specification.
These are absolutely not capable. And the
Yeah.
second concern is that the packaged drinking water, these companies, that they are extracting water from the underground, and in localized area they are depleting the underground source of water, because the infiltration in the underground water is unfortunately not at the same rate. So, means, what do you feel in this?
I think it's a state issue. So many state governments limit the amount of water you can withdraw from that place. That is true for all our packaged drinks also. So they're restricted by the state law. So if you think that too much of it is being taken out, then you put a ceiling. That's why in one of my earlier slides I said regulation in this space. Water is required by everybody and equally. So you need regulation.
Thank you, sir. So if you have any other questions, please interact with sir during lunchtime. Let us thank the speaker once again.
Thank you. Please. Windows pane. Don't just pull it down. You know how
Okay. Eject.
eject.
We extend our heartfelt thanks to our plenary speaker for delivering such an inspiring and knowledgeable presentation. Your insights and expertise have greatly enriched our understanding.
Now we proceed with the plenary talk. We have our esteemed guest, Professor Dr. K. Srinivas Reddy, IIT Madras, sir, to present a plenary talk with us today.
Now, I would like to request Dr. Basant Singh Sikarwar to present the Tulsi sapling to our plenary speaker, Professor Dr. K. Srinivas Reddy, as a token of gratitude. Can we have a huge round of applause for him? Thank you, sir.
The topic of his talk is Solar Energy Systems for Sustainable Process Heat and Power Generation. Dr. K. Srinivas Reddy obtained his PhD from Indian Institute of Technology, Delhi in Energy Studies in 1999. Professor Reddy is a Fellow of the National Academy of Engineering, Fellow of the World Society of Sustainable Energy Technologies, and Fellow of the International Society of Energy, Environment and Sustainability. He is specialist in renewable energy with special research interest on concentrating solar power, energy efficiency and environment. Now I request you, sir, to kindly deliver the plenary talk.
Thank you. Good afternoon to all of you. Either, ठीक है? Thank you very much. At the outset, I thank the organizers for giving me an opportunity to give talk on this solar energy. As Professor Muralidharan mentioned about the solar energy for desalination, I speak something about solar energy systems for process heat and power generation, mainly when you come up with solutions. General introduction is energy is very important. There are several problems which we are facing. Energy cannot be addressed in isolation, the energy problem. So therefore, we need to go with environment as well. So energy can solve many problems. And if you broadly classify energy sources, there are two types: celestial and capital. Celestial means the energy which comes from the outer space, which includes solar energy. The capital means fossil fuels. So therefore, these sources are classified into renewables, fossil, and so on. So a typical energy system hierarchy is energy source, carriers, and equipment. So therefore, my talk is mainly on renewable side. So the primary energy is translated into secondary energy carriers and subsequently used for this one. If you look at the energy services and timeline, I think what I'm going to say is after industrialization, the commercial use of fossil fuel use started, but I think we are looking for a net zero scenario by 2070. So the hydrogen is one of the options for future. So therefore, as you know that the Indian energy target net zero is 2070. So therefore, we have to look at that. The global energy potential, if you look at the solar has a highest potential for catering the energy needs of present world as well as India. As you have seen this, we had a disruption twice, energy disruption. If you look at global energy demand prosperity, wherever is the earth is illuminated, that means you have a energy demand and prosperity. There are several countries under energy poverty. You can see here there are many countries under energy poverty. So therefore, we need to address the problem of energy. Generally, this energy problem is addressed in three ways: accessibility, availability, and affordability. Though energy sustainability is very important, we deserve that. We want to have a luxury energy system. You know that most of the technologies, fuel and infrastructure is all imported. So therefore, we may deserve for this, but eventually we may land up into this if we don't go for energy sustainability. So energy sustainability is very important. Earth is in bluish color because of indiscriminate use of fossil fuels. We are literally imbalanced in the system. Any imbalanced system looks like this. So in want of time, I'm a bit rushing. So energy sustainability is important. So if energy system is like this, if you drain, the energy sources are limited, mainly fossil fuels. As you drain it, then as you consume it, they may exhaust after some time. But an alternative option is you go for with the technology. This technology keeps energy sources for the future generation here. So therefore, this technology is important to keep the sources consumed in a sustainable way. So this technology, according to me, is a renewable energy technology. So the future generation says that there is only one earth we have to take care of. So what to do? Then your money, your environment, your resources. So therefore, energy is important. Now I will discuss the topic because as you know that how energy disrupted twice here in our seminar room itself. So therefore, sustainable energy system is very important. And solar energy can be converted into several ways, like you have indirect conversion and direct conversion. So in direct conversion, it can be through thermal route or direct photovoltaic route. So I'm going to concentrate on the thermal route here in this talk quickly, what we have developed technologies at IIT Madras. And the sustainability can be attained in through renewable energy technology, which results in development, energy, and environment. And if you look at most of the globe, especially in this area, you have a good solar radiation, so therefore we can utilize it. So the most important thing is in India, across the world, the major energy consumption is in the form of heat. 2/3 is the heat and 1/3 is in the form of electricity. So therefore, it is important how to utilize energy effectively. Any heat which is less than 260 degrees Celsius is in the for process heat category, and if it is greater than 60 degrees Celsius, it's a power generation. So industrial processes, there are several industrial processes in which they require heat, and these are some of the process heat systems. And if you that because we are working with several industries and we have given several solar solutions to industries, and there's a wide range of industrial process heat applications you can see here in terms of these categories. I'm not going to do this, and these process heat requires mainly 62 to 60. The minimum temperature is 60 degrees. maximum is 260 degrees. So therefore, we can give solar energy conversion effectively in this temperature range. So therefore, we can address any industrial process heat problem through this. And power generation, as you know, that the power plant is based on thermal power, mainly thermal power generation, and is based on first law. I'm not going to discuss in this detail. And if this heat supplied by fossil fuel, if we replace it by solar energy, then it's called solar power plant, which we call as a CSP, concentrating solar power. So this part, which is in a boiler where the heat is added by fossil fuels, if you replace it by solar, it's a CSP. So, but otherwise it's almost same. The technology same. The power plant is not so simple. So this, if you replace this part by solar system, it's called solar power generation. So the process heat is somewhere 260 to 260 degrees Celsius heat. Power generation, we can go anywhere maximum supercritical, ultra supercritical range. So here, what I mean to say is this place, we are essentially replacing it by a solar system. Some of those I'll explain. And this, as I have already mentioned, this I think, sir, this is a basic process heat and power generation. It looks like this solar process heat. There are solar collectors which convert solar energy into heat, and that can be used for heat loads. Here, either you can make it more reliable by storage or auxiliary system. So energy storage is also gaining, as you know, that a lot of research being done, and including our group, we are working on energy storage. And if you go for power generation, in between you need a cycle or a heat engine. So therefore, the collectors, almost same collectors, can be used to supply the heat to the power generation. So, as for I have given you the brief introduction of solar process heat and power generation, and at IIT Madras, our group is working on various technologies through 4D approach: design, development, demonstration, deployment, and of course commercialization. Also, some of our industrial associates commercialized. I have listed here about 20 technologies which we developed at IIT Madras, but of course some more added recent times. These are mainly based on process heat and power generation. This is our lab at IIT Madras and students. So as I've already mentioned, that there are, just now I mentioned power plant, power generation, CSP, concentrating solar power. The boiler is replaced by solar system. And if you look at, there are 4 solar technologies have reached to the maturity for power generation. Those includes here parabolic trough, parabolic dish, power tower, and linear phenol reflector. We are working on almost all of these technologies. As I mentioned, that 4D approach from design to commercialization level. The medium temperature technologies are below 400 degrees Celsius, and anything above 400 is a high temperature. As you know that power plant efficiency improves as the temperature increases. Higher the temperature, better the performance. So therefore, we can now even supercritical power generation can be done by the solar power plants. So these are some of the technologies which we developed at IIT Madras. This dish, trough, and so on. And they are, as I mentioned, that is a 4D approach. So therefore, most of our system, I also find this 4T. It is from test tube to technology development. Test tube, tabletop, and technology development. Most of our technologies are at the demonstration scale, so that they can be taken to the field directly and implemented. And some of our industrial associates, they have already been doing. So these are solar dish, PV, and parabolic trough, and concentrating photovoltaics, and so on. And the other, as I mentioned, that if you look at the other view with respect to this, most of them are in the lab. We have developed demonstration level scale, so that they are at the TRL level of 6 or 7, so that the industry can take it forward easily. So this is one such system. Here you can see. And when we go for power generation, these industries, they come to us, and if you install solar power plants, how much they will give. So therefore, we generally give DPRs to the industries. So as a part of DPRs, we have studied the entire country, India, how if these technologies are placed, what is the land requirement, because land is more expensive now, land requirement, and what is the levelized cost of electricity, And what is the environmental benefits? We call 4E, energy, exergy, environment, and economic analysis. So 4E, 4D, 4T, and of course the other fours also 4As and so many fours. So we studied these power generation for entire India and proposed three conditions: one, viable areas, conditionally viable, unviable areas. This blue color, you can see them better. The blue color, I think all of them look same, but here it's looking better. So and green color is the viable areas. Blue color is conditionally viable. Red ones are not viable. Even if this technology implemented, it may not be viable with present conditions. So therefore, this is a kind of a reference to any industrial partner, that whether they really install a power plant in what location and where they want, and what is the I think some values are there in that. That value is a levelized cost of electricity, energy generation, and also what is the environmental impact on this. So this is another technology, parabolic trough. We have a test bed at IIT Madras. As you know that this is this is a commercial test bed. And we can test the any concentrating systems here. This is an industrial processing system, and the other one is a power generation system. It's a standard, internationally standard collector. You know that across the world there are several power plants based on these technologies, and some of our industrial, even you have seen in Anantapur, and I think there are 3-4 plants in India also working at that level. This is another concern. We work with Fox Marshall, and this is a Fox Marshall technology. This is another industrial associate where we can go for hydrogen, high concentration. It can go up to 2500 degrees Celsius and so on, and with a high more than 1000 concentration ratio and so on. So this is such systems we work on laboratory scale in a simulated condition. These are simulators within the lab. And if you again any in 4D approach, it starts from optical, structural, and thermal analysis. We go from basic optics to thermal as well as structural, because most of these plants are outside, so therefore they have to withstand gusty and cyclonic conditions. So therefore structural stability is also very important, and optically it should be accurate, and thermal should give good output. So we worked on various technologies. Some of our industrial associates, they have installed in pharmaceutical industries, dairy industries, and tanneries, and the other one is textile industries. So this is one such system we installed in a school. It's a tri-generation system. It's a G.D. Krishnamurthy Foundation School in Patashala, about 70 kilometers from Chennai. It gives power, heat, and cooking, as well as air conditioning and water production. It produces more than 400 degrees Celsius. And this is another our industrial associate in Coimbatore. It produces steam here. You can see that high pressure steam is coming out, so that it can be integrated to this. And desalination is one of the important. So desalination can be used for effluent treatment as well as potable water production. So this is a system which is in Tirupur textile industry. We installed one solar system for effluent treatment, because as you know that our Indian textile industries are under stress, because they have to face the competition internationally, because Bangladesh is one of the competitor, and so therefore textile costs are going up because of the effluent treatment. So this is one such system. And we also work on other desalination with because we have to make it cost effective concentrators. So therefore this such one cost effective affordable concentrator, which is a passive. Active systems require energy as well as the cost and complexity also. So therefore, how to reduce complexity, cost, and reliability. This is one elliptical hyperbolic system where it concentrates solar energy in forward direction, again used for desalination purpose. We work with desalination plants. So this is Professor Muralidharan also mentioned about evaporation condenses. We have published a book on thermal desalination. If you want, you can look at that. Solar thermal desalination with all technologies together. So this is one such system. Evaporation condensations happens in different units so that the yield is higher, and it can be used for both brine and normal potable water. There's another, of course, this all students work. So this is another desalination system. It's a vertical still which produces the potable water, and this is another water for wastewater treatment, another system for wastewater treatment. If you want details, you can get from a web page. All those are available. And another important, Swachh Bharat is another important. So therefore, how to come up with a zero discharge toilet. So as a part of that, we studied how to use solar energy for human waste conversion into fertilizer. So this is a synthetic human waste we studied to in the process of developing a even zero liquid, zero solid discharge toilet. This is the first step to do that. Desalination and as well as the drying systems are used. And these are another photovoltaic system where you have a concentrating photovoltaic systems where cogeneration is possible. Here cogeneration, trigeneration, it's a triple junction. So see, normal photovoltaics are in the order of 15 to 20% efficiency, but you can improve the solar cell efficiency by concentrating solar radiation onto that. But the problem is the temperature will go up. When the temperature goes up, the performance comes down. It's like a contradicting. So therefore, you increase the solar radiation on the cell and maintain the cell temperature so that you can recover heat as well as you get a higher efficiency. As a part of that, we studied developed this technology using triple junction solar cells, not silicon solar cells. And we are also working as an Indo-Canadian project. This is affordable net zero energy buildings. It is because some of them are unpublished, so I have not shown clearly, and say some of them are under development. It's an integrated both wind, solar, and then waste solid liquid discharge treatment. So it's a comprehensive system. I think we have already built this at IIT Madras, and we are going to give this technology to some of our industrial associates. And this is what I referred. This is a net zero discharge, zero discharge toilet, which is installed in our Krishna hostel. You see that the solar zero waste discharge here. It is a completely hermetically sealed. Liquid, solid are separated, and then the liquid is treated and circulated back to the flushing, and solid is converted either to fertilizer or a biomass. So you can see that this is a desalination here. This is the drying system, and there is a bottom under this. Underneath you have a separation system, and they brought to the top by these solar panels, which power the motors. So another integrated, we installed in Vishwa Bharati University there in Shantiniketan. It's a hybrid power plant which gives the power, cooking gas, and water in a tribal village. This is a no man's land. It is under Indo-UK project. We installed both biogas and solar panels, and then CPV integrated here, and you can see that this is a biogas driven generator, and you have a battery storage. It's completely, there are 60 hertz, and we also used electrolyzer to produce hydrogen and to increase the calorific value of the biogas. So this is such system. So we developed before installation, we developed these at the lab. So all the lab things are over. So I think this is more than enough for me. I will complete soon. So I am ending that. With these technologies, I come to the conclusion that the optimization of energy system for sustainable development can be done both numerical and analytical, because some of students are here. And 4D approach is our 4DC, design, development, demonstration, deployment. And of course, when we associate with TRL 6 to 7, and if you go beyond that, the commercialization is also possible. So some of these technologies which we developed at IIT Madras for process heat and power generation I have shown, because the time is less, so therefore I went fast. And I think organizers introduced. I am from IIT Madras, and IIT Madras is some of you have visited, most of you have visited, and it's a sustainable campus, very good campus. So we have friends like this here. Our friends are there, and my friend is here is looking to you. If you have any questions, you ask this person. I'll answer on behalf of that person. Thank you very much.
Thank you very much, sir. Due to interest of time, we'll take only one question.
Sorry if I rushed because I have to go.
Just only one question.
Yeah.
What is economic and environmental comparison between solar thermal power generation and photovoltaic power generation? How feasible it is economically and environmentally? Is there any comparison?
Comparison is good, and environmental and economic point of view. Now I think if you look at the overall end-to-end solution, thermal is better than photovoltaics, because now I am doing some work with photovoltaic systems also. See, most in India now we are claiming that 30% installed capacity is solar PV, and those plants which are more than 10 years old, now they are getting problems. Now we have to replace most of the panels, and one of our industrial associates, some 6 megawatt plant, we are doing that, and almost 50% panel we need to replace. And major problem is the recycling. How do we recycle these panels? And in another 5-6 years, recycling become a big industry. So therefore, in recycling point of view, thermal plants are much better, and that is the energy as well as environment point of view. Only thing is, if now storage comes into picture, and I think in China, US, everywhere, a lot of work is being done on CSP with the storage. So I think future is going to be CSP with the storage, economic point of view, and all. Thank you very much.
Thank you, sir.
Thank you very much. Thank you for your.
Sir,
Thank you, sir, for delivering such an inspiring and thought provoking presentation. Your insights and expertise have greatly enriched our understanding.
Now, proceeding with the plenary talk, we have our esteemed guest, Professor Dr. Anlip Tariq, IIT Roorkee, to present the plenary talk with us today. Now, I would like to request Professor Dr. Basant Singh Sikarwar to present the Tulsi sapling to our plenary talk speaker, Anlip Tariq, Sir, IIT Roorkee, as a token of gratitude. Can we have a huge round of applause?
The topic of his plenary talk is High Speed Imaging Progress, Challenges and Future. Dr. Anlip Tariq is working as professor and head in
Okay.
Anlip Tariq is working as professor and head in Mechanical and Industrial Engineering Department in IIT Roorkee. MIED is one of the largest departments at IIT Roorkee and presently carries an overall research grant of around $9 million a year. He carries the endowment chair position of Hindustan Aeronautics Limited. Chair professor at IIT Roorkee, he has extensively worked to popularize the liquid crystal thermography (LCT) and practical image velocimetry techniques in India for various thermofluid application areas and is known as the pioneer researcher who started the usage of LCT.
The topic of his talk is Industry Academia Integration and Sustainable Development. Now I request Sir to kindly address the gathering and start his plenary talk.
दिस थर्ड नीचे से था ऊपर उसके ऊपर दिस इज पीडीएफ ओपन दैट वन नहीं नहीं जस्ट शट डाउन इसको बंद कर दीजिए इसको बंद कीजिए आप ये ओपन कीजिए वो फ्लैश यूएसबी ये उसकी मतलब हाँ दिस वन Good afternoon. I think we have heard technical sessions. This topic is slightly different, and I thought the idea here is much more related. I tried to make it aligned with the flame basically, and already Professor Murlid has talked about the sustainability and the water, that importance. So that will be one of the theme. So I am Andalip Tare, and coming back to the theme, basically, the idea here is that to inspire as well as to educate the audience, especially the students, basically. And it is pertinent from that perspective that what is the present, how the present growth is going on. I'm talking about the scientific growth and what are the futures, basically. So we can see this figure, the kind of growth, the growth rate which happened till 2000. If we go by that pace, so within 100 years, we are going to witness the growth rate of 20,000 years of progress again. And it means that the civilization is changing, seeing the change, technological changes very fast, very fast. And on that way, many new things are coming into picture. Although these were earlier in the laboratories or in the practice at the institute level or at the academic levels, but they are making the sense in the real life applications. And in that series, we can say that the advanced robotics, that is one of the area, artificial intelligence and machine learning, we can see the boom basically, all the branches, all the institutes are just going in that direction. They are working with the robotics or artificial intelligence, data sciences and all that. So this is omnipresent everywhere. And next, okay, the idea here is that we have to relate that all things with respect to our own mechanical engineering. How we can deal it, and is it really different or it works well within the periphery of the mechanical engineering. So then the autonomous transport system, we may have heard about the Tesla and all that. Many of the cars, they are coming and they are working extremely well for the driverless kind of things. For that, we are again working for the advanced materials also. And then Internet of Things. All we know that
the communication. It is the era of the communication, and things are changing so fast, and it is mostly due to the communication advancement, we can say that. And then the 3D printing. This is also, we have witnessed that until now, before that starting of this decade, it was something we were at the industrial level, we were working with the conventional kind of fabrication, conventional kind of manufacturing. But after the advent of this 3D metallic printer, as well as the polymer based and all that, things is entirely revolutionized. And the moment it became present for the public application, it has crossed that threshold. Basically, it is in the market. Basically, so what happened? Everybody has started. So in that way, it has certain lot of advantages, and this is another area. And I will say that nothing is complete without, if we bring that into picture. We know that what happened long back, I think last 2 decades back, there was a genetic mapping program of the US basically, and that what they started, that it was very heavily funded program. And initially the big nation, developed nations were the real leaders in that way, and they ask you, okay, you have to, if any country wish to participate in that project, genome project I am talking about, they have to pay some lot of money, fund it appropriately, then only they will allow. But what happened at the end, basically, once the genetic mapping get completed, then it has created so much of enormous data that it became very much difficult for the humankind to process it and come out with the meaningful. So, and they have opened there. Right now, the data is completely open, accessible to all the members of the planet Earth, and they can access it. And this has revolutionized the things. We are working with the target medical target drug delivery and stem cell. Lot of things are there. So means biomechanics and all that. So this is also one of the hot topic, we can say that. And summarizing all that, what we can see there, we can see that we are at the brink of the technological revolution. Okay, and what is going to the outcome of it? The outcome is going to, in that way, the kind of job which is available in the market, the kind of people which is available in the market, they are going to be the obsolete. Almost 65% of the future labor is going to be swept by the demand will be entirely in these fields which we have talked, starting from the robotics, artificial intelligence, genomics, and all that, materials, new materials, and all that. So it is we are at the cusp of a revolution, we can say that. If we are not geared with that one, it will be extremely difficult, and especially from the Indian context, we are so much populous, and that too the young population. If we cannot reconfigure it, it will be entirely a difficult and complex kind of situation, how to deal the employment and how to increase the employability, and where our labor or as well as the technological manpower will go on. So we can see, to understand the importance of this revolution, if we are not ready to revolutionize it, we are not going to change it, what is going to happen? So we can see this timeline. We remember that the engineering, basically, that what we talk about when we started mechanical engineering, we think about the James Watt engine. And that was the era, I think, in the late 70s, or you can say that just prior to the 1800s, the engine comes into picture, and the whole sole power was steam driven as well as the water driven. That was the whole thing, and that was the major thing that has given the impetus to the growth of the civilization, and that we termed as the first industrial revolution. Later, next, basically, comes the second industrial revolution, and that became when the electrical energy came into the picture for the real application, for the printing, for the industries and all that. So that has again revolutionized. That was the second turning point. If we will see that, okay, what has impacted the civilization history, so we can say that that era, that was the one thing. Next, the electrical revolution, electrical power that came into the practice. And I remember that there was a very famous proverb by the Edison, I will make electricity so cheap. I will make electricity so cheap that only the rich can afford to burn candles. And right now it is happening. We go for the restaurant and go for the candlelight dinner. That is very costly. And electricity, everywhere it is LED and tube lights and all that. So that was the second revolution. And after that, what happens? The electronics, low current, low voltage technology comes into picture. And still many of the ITs still deals the electronics under the umbrella of the electrical. I think even in the IT Kanpur also that is happening. So that was the second, third revolution, and the chips and microcircuits and fabrication technology of the that ICs that came into picture, and that has given a major change. That has given the major change. And after that, I think this is the fourth revolution. We are cyber physical systems basically. This is going to revolutionize. So time is moving. If we are not going to change as per the demand, we know that the tree which is very hard and stiff, it is not flexible to change. That just get out of the again in the storm basically. So thinking, I mean, seeing the writings on the wall, this is the high time to analyze that. Okay, what kind of future technologies, what kind of future requirement is there for the future education as well as for the industry, so that once we can deal it and we can provide the sufficient manpower as an academic institution, and industry also has to reconfigure. So for that, what kind of skills are required and what are the responsibility? So we are trying to correlate all that. In that way, there are two things. The industry are going to generate, as I said, the future generation, or right now, now onwards itself, we can see that the majority of the jobs the industry are going to offer, for which we don't have the sufficient trained manpower. And if we are not going to deal our education system, academia, reconfigure it in that manner, then 65% the growth which is going to be expected as per the data of the different commissions, then India participation, our young blood participation will be very less, and we have to deal with the unemployment, and we will deal with the kind of workforce, those who are not trained, those who are not skilled to deal with such kind of development. So that is the major crisis. For that, I will just give you the, okay, what kind of things are required. So according to that World Economic Forum data, if they have categorized the hierarchy, okay, in 2015, what was required? We remember when we started our master and doctoral program, at that time the mathematics was at the peak basically. Everywhere, I remember when I have gone to just give the interview at IIT Kanpur, every times they ask the mathematical equation, either even if it is dealing the fluid mechanics or the heat transfer or the mathematics or the electronics, whatsoever is that. So complex problem solving, that was at the highest priority in 2015, we can say. Coordination with the others, people management, human management, that is treated to be very difficult task, because human are extremely difficult to predict. It is a very complex system. As always I say that, okay, artificial intelligence is something, but human intelligence is beyond that. It is difficult to model. That is the thing. Then critical thinking, negotiation, these are the quality which for which industry we are looking for. Okay, if we need the manpower, what kind of quality he should have, and there at the creativity at the 10th level they have marked. Then in 2020, there was a within 5 years, you can see that the pace at which the demand is changing. Within 5 years, what happens is the creativity comes at the third, and other things, cognitive flexibility, negotiation, they have gone at the back. And as far as if we analyze all that and see the previous past data of the decade 2010, 2005 and all that, we can say that in 2025, what is going to be the major thing which is the industry people are requiring. And for that, we have to reconfigure our curriculum, we have to reconfigure our style of teaching, so that we can deal with that one. That is going to be the critical thinking is going to be at the top, and creativity. And then later we can say, we can debate it, okay, complex problem solving will come, or the people management will come, or the negotiation, other qualities will come. So with all that, now the role of the industry and academia became very much critical, because for all that, industry needs certain set of people carrying certain set of quality, as we discussed, the critical thinking, innovations and all that. And if we are dealing the subjects, or we are training our students, training our manpower in a conventional manner on the conventional subject, it is going to be the disaster. They have to work together, industry have to work together, they have to sense the thing, because what happens actually, suppose right now in all of the ITs we have gone through the curriculum change under the new education policy. It will get implemented, it will come into the practice, and we know that the market change very rapid. In academic, in the rigid environment, or in the kind of syllabus revision through the committees, when it comes into the actual existence, it might be possible that by that time the complete demand will get changed. So it is very difficult if there, because in the academia they have to go by certain, that is the advantage also, because if we will change it very quickly, so it might be possible, that is not very healthy. But there has to be certain balance. And for that, the role of the interaction became very much powerful. That became very critical. Okay, how to deal that? There should be active involvement. And for that, the one thing is that the education. Education, what kind of education should be there? What kind of subject should be taught? And what should be the way of teaching? What should be the way of engagement? So that our students should be get trained with the necessary kind of a skill, the necessary kind of in which communication is also one of the important things, and so that we can deal with the industry demand and we can supply a proper kind of human resource. For that, I can say that okay, university strength or lies in the talent, because okay, industry strength is something like that. Okay, they have the university get sufficient manpower continuously, and university, and there are two things: learning outcomes and the pedagogical model, and we have to deal in tandem basically. And for that, already we in this passing decade, it has been generalized that the STEM jobs are going to be, they have science, technology, and engineering and management. These are the four factors on which we can see that in 2010 and then 20, something of that, so many percentage I am talking about, how it is going up to 62% will be taken care by the STEM jobs. But again, the big question is that the way in which we are predicting, or the need of the STEM, is it sufficient to deal the future generations, or to deal the requirement of the planet, or to deal the industry requirement as the civilization requirement also? Because there is one thing, technological development. There is other aspect we tend to forget, is that all the technology, all the development, it has to for the human being, for the planet Earth, and for the civilization to sustain. For that, all these models has to be human-centered. It has to deal, because suppose right now we are dealing, everyone is using the mobile, and our screen time is too high, and we don't know that what kind of cognitive behavior it is changing, what kind of adverse effect of continuous screen time which is coming. We know that all of our children's of this generation, they become very hyper, they are too much screen sensitive. So many things are coming as the byproduct, or we can say at the adverse product. So there has to be a certain regulation for everything. Okay, what has to be done, how to deal that kind of things through with the help of technology interference, or through certain regulation with the help of society participation, as well as the government participation. So everything has to be human centric and the creative thinking. Okay, summarize. We have to, what we can say, that we have to change our education model basically. And just now I dealt it. And for that, we can say that the way in which we are teaching our students, the way in which we taught our subjects, conventional subject, how much it will be much more impact. Because it is knowing is one thing, we have to create the human manpower in such a manner that They should know the fundamentals. They should utilize it. They should convert that ideas into the product, and they can generate the job revenues also, and they can self-sustain it. And automatically the other thing is that their cognitive behavior and everything that has to match with a healthy pace, so that it should not happen ki, okay, technologically we are going advanced, there is an advancement in one direction, but as a civilization, as a human brain, we are depleting, and our physical system, biological system is not matching with that pace, or it is going in a different direction. That may be a disaster again. So that all has to be thought in. And then comes the social responsibility. Social responsibility means, and I think all the government agency, most of the country are going in that way. There exists a requirement that social responsibility for the industry, they should spend certain percentage for the upliftment of the society. They have to pay back whatsoever is their balloon, whatsoever is the profit. Certain percentage has to be paid back to the society for the betterment. Otherwise, this model is going to not sustainable. We are creating a particular class, elite class or kind of industry, and we are not playing a positive role for the society. That is has to be regulated through this or that. And similarly, academia also has to utilize that. Okay, if industry is working forward, they are spending money, they are opening some centers, and some fundings are there for all the education system. Then what kind of manpower we need to create so that it can meet the industry demand also, and they can be employed. And what we at the start we talked about certain kind of subjects, certain kind of approach, and again we have to come out with okay, this we can say it is a triangular thing: university, society, and industry. It has to match together, and they have to both have to support. That common leg is the society. Industry had to decide that we have to support the society with the help of academics, and academic people has to make them relevant. They have to serve the society with the help of the corpus as well as the proper engagement of the industry, so that it can get sustained. So this is very much important. And as I said, innovation, that is the basic requirement. Creativity, because just dealing the student, making them rota technique, they go through, memorize something, they know everything. Just like the Google, they will answer something. Okay, what is this first law? What is second law? What is this one? They can answer it, but that is not going to be the sufficient. And that is right now, I think, because mathematics, complex problem solving, we have a lot of softwares, lot of things are there. So we don't need, I think already without the calculator, new generation cannot do that simple arithmetic also. And it might be possible, it is not much required. It should not be that much emphasized. In our school days, it was the mandatory, we should remember the tables 2, 4, 3, up to 20, something like that. Now we have completely changed the perception. Similarly, it is not required to completely understand and everyone start writing the code and understand the very complex mathematics. Very reliable softwares are there. They have to be utilized intelligently, intuitively. So, and the basic thing is that it has to be innovation. And innovation, I can give you the example. I think just with the limited time, what I can say that, okay, with this collaboration, we have to sustain, it has to be sustainable one. Least impact on the society, environment, and create the future leaders. And for that, what is happening right now in all the academic institutions through the government scheme or the partnership, we are creating different central park, technological parks, and that can play a very positive and active. And again, it should not be like our show business. Okay, everyone institute have certain parts. It has to be utilized in a synergized and synergized manner that it can play a very significant role. I can, and for that, ITs are playing good roles. A lot of centers are coming, and at the heart of the IIT, we are government through with the help of DRDO, with the help of spacecraft agencies, ISRO, and with the help of other agencies. Some technological parks are coming into picture, and they have the advantage that they are muscular, they are flexible, they don't get guided by the bureaucracy norms of the original parent organization like the DRDO or the BARC or something like that. They have certain flexibility of the academia also, and it can, if it is utilized in a proper manner, it can do wonders. And for that, we have to define. I think again it became a management task how to define the vision, strategy, roadmaps, and all that. That has to be dealt very properly, very well defined. Then only it is going to pay the results. Otherwise, again, it will be a big show, lot of hue and cry, lot of things will be there, but outcome may not be that much tangible what we are looking for. And with that, I think I will just close. Okay, innovation, I think one example I can give it, why it is very important rather than the other talents. Suppose many of the things, invention has reached a peak. Making an iota of change is extremely difficult in that field. But with the help of it, suppose I have seen that in the last year, my father, he's old basically, and in the room, suppose he wake up in the night, and either he has to open the switch or there should be night lamp or something like that. My younger brother, he just ordered it. There is a night lamp kind of thing that is motion sensitive, and it can be plugged, and it is very cheap also, 100 rupees or 200. It can be plugged inside just at the floor height basically, and room is completely dark. When he wake up, he started moving automatically. Bulb will glow, and he can see where is the door, and he can go for the washroom, something like that. So means that simple innovation can generate lot of revenue. It is very least cost effective, but it contains lot of dividend, and it can be it can save the power. It can give the, again, as I said, everything has to be human centric. If we are too much oriented with a STEM model, that is going to be disastrous right now onwards. So with that, I think I will just take one slides to introduce my institute. I am representing IIT Roorkee. Again, it has a strong legacy. It has finished 175 years in last year basically. And in our department, we offers different things. We are reconfiguring. And just recently in our department, I think in IIT Roorkee, mechanical is the only department we have adopted an entirely new kind of approach under the NEP. And I can say that except mechanical, nobody has opted that model what we propose, and I was successful to transfer that into the reality. Let's hope it will give a very good dividend. And the idea behind it is that whatsoever we have explained, I have explained it. That was in the mind, and a lot of centers are coming into the picture. With that,
Professor Tariq. It's a nice talk.
I thought I just talked about the common sense, and generally it is said that common sense is highly uncommon. So there should not be any question because it is a very common thing. What I it was not technical anyhow.
Yeah, I have one question because you told about that comparison between 215, 20, and 25. And if you look at 20 and 2020 and
25 is my own projection.
Oh, your own projection. Okay, so 20. So
up to we can say up to we are right now. That forum has not released the data.
Yeah.
What is going to be the most likely thing?
So what I see that complex problem solving essentially requires both critical thinking as well as creativity and perhaps innovation also. So why we are ordering it?
I think the creative thinking is missing in our curriculum. Generally, we can say, creative thinking, it is very difficult. Our education policy is not designed, or the manner in which we teach the subject. It is not like that. Creative thinking aspect is getting lesser attention. And the students might be very good in solving the complex problems, formulated, but beyond that, they require another approach. They require an additional skill, or we can say that is going to be because many things whatsoever mathematical modeling and all that. Okay, certain things are required at the research level, certain set of people, limited number of people should do that study, but we are talking about the masses. If everybody is expert in solving the complex problem, then who will provide the innovation, who will deal the real requirement of the society? For that, creative thinking, just I have given the example, that kind of things, and it will generate the employment also. Does not require any additional tool. It is not burdened. It does not require too much infrastructure. Does not require too much money. And you can see that earlier there was an approach to become the billionaire, to rise or to create a industry. Initially, the idea was that we need lot of money, we need lot of infrastructure support. But right now, thing is that you need idea. You can see that there is an in-short application. It was nothing within 5-10 years back. Right now, it has created a multi-million dollar kind of business. So the idea here is that creative thinking and innovation, these are the prime factors that is going to be sustainable, that will give them, and that is the need of the hour. And we should not depend upon if we have that much money only, then only we can start the industry. And people's entrepreneurs should be there, and those who are funding it, they need the person who has the critical thinking, innovation kind of thing, rather than a industry cannot be established if you will give me money. If the critical thinking or innovation is not there, then that industry is going to just collapse.
Correct. Can I ask one more? So on a related note, because you're talking about curriculum, see, AI is going to pose a major challenge to evaluation in particular when we talk about curriculum. So what are your thoughts on that? Because see, as I said, critical thinking and innovation essentially.
That's why, again, I think we can discuss afterward. That's why I said AI is one thing, but again, it is not going to give the solution, and again, it has to be judicially restricted. AI can give you the idea where is the target, where to hit it. Suppose we put a drone and we go to the enemy territory and it can hit it. But we have to regulate, we have to decide it. Suppose it harms some civilians. Who is going to be the responsible? Is the software glitches there, or it is the technological things or instruction or the person who is giving that command? So lot of regulation comes into picture, lot of things, ethics comes into picture. Because right now it became drone creation technology is became very easy. It became very cheap. Earlier in the past, it might be any very rich nation can afford it. But with that, suppose it became a tools in the even common masses, how to deal that? It will be something difficult to handle it, because who will be responsible? We have to regulate it. AI is not going to give the solution. It is a tool and it has to be cut short where it has to be improved.
Thank you, sir.
Now I request Dr. Basant Singh Sikarwar to felicitate our plenary speaker, Professor Dr. Andilip Tariq.
I request Dr. K. Muralidhar sir to please come forward for the felicitation. No, to receive the felicitation.
Now I request Dr. Basant Singh Sikarwar to felicitate our
For guest speakers and session chairs, the lunch is in F1 normal launch, and for all other participants, it is in F2 foyer. Thank you so much, everyone.
Good afternoon and a warm welcome to our distinguished guests, esteemed faculty members, teaching staff, and all students attending today. I, Krishna Bansal, along with my colleague Parth, will be your host for this keynote talk. We are delighted to welcome you for the fourth Pioneer International Conference on Future Learning Aspect of Mechanical Engineering, FLAME 2024. organized by the Department of Mechanical Engineering, ASET, Amit University, Uttar Pradesh, Noida.
I'd like to introduce our session chairs for the keynote talk session, Dr. Ritupurna Datta, who is working as a manager in data science with Capgemini Technology Services, India Limited. Prior to that, he was a computer research scientist and adjunct faculty in the Department of Computer Science, University of South Alabama, USA. Our second chair of the day, Dr. Ishbir Singh, is not yet joined us and will be joining us shortly. Once he'd be joining us, we would be giving an introduction about him. Moving ahead, now like to request our session chair, Dr. Ritupurna Datta, to, along with our coordinate, Dr. Umesh Watt, sir, to present the Tulsi sapling to our keynote speaker, Professor Dr. Sutapat Wangkao Meng, as a token of gratitude.
Thank you.
Today, our keynote speaker is Dr. Sudhapat Wangpameng, Professor in Mechanical Engineering at KMITL School of Engineering, Bangkok. The topic for the keynote talk is Heat Transfer Enhancement on Stirling Engine Heater with Biomass Fuel Combustion System. Professor Dr. Sudhapat is a faculty member in the Department of Mechanical Engineering at King Mongkung Institute of Technology, Ladbang, with a background in a mechanical engineering. Her expertise spans in a renewable energy, particularly in solar thermal system. Her research contribution includes innovative design for solar cookers, geysers, air heaters, and solar water heaters, aiming to advance sustainable energy. Dr. Sutapat has actively contributed to education initiative and published research in international journals, demonstrating a commitment to advancing knowledge in renewable energy technologies. Now, I would request our session chair to take over the session and ask the keynote speaker to deliver the keynote address.
Thank you very much for all staff here and also all audience here. It's such very honor for me to present my work and also share some of the progress that I have in the laboratory, especially about stirring engine. And the topic that I would like to carry out today, heat transfer enhancement. What can we enhancement for the heat transfer? In order to improve the system and also thermal efficiency that we can gain from any components that we can make it from smart materials or even smart design. And for on the Stirling engine heater, so we will focus on the heater part because this part is the most important thing, because if we have heat supply and input to the system, as much as we can. So we can convert heat in terms of work or power that we need. And yeah, using biomass fuels, combustion chamber, because now we focus on some renewable energy. How about the base load? If we talk about base load, the power that can produce all day, all night, we cannot refuse that biomass can do that. If compared with solar energy or wind power energy, it depends on season and also daytime. However, today I would like to introduce about my university where I'm from. So this is King Mongkut Institute of Technology, Lat Krabang at School of Engineering, the biggest engineering school in Thailand, and we are aimed to be the land of skills and opportunities. As we know, we cannot have single skills and we cannot have just only single disciplinary. We need to have multidisciplinary. So all opportunities and pathway that we create and pay for students very important, not just only for students, but we also have for alumni and other people that would like to reskill and upskill them. And you can see some fact sheets that we have. We have almost 10,000 students, including bachelor program that we have is going to be regular program using Thai language and also international program. Not just only bachelor degree, we provide for a master and also doctoral degree as well for graduate students. And let me show you something a little bit. So this is, I really aim to have, some collaboration with many professors or students that would like to go and obtain some opportunity of King Mongkut Institute of Technology in order to conduct some research work together in the near future. I hope that your university tag or logo will be placed on this map of King Mongkut Institute of Technology, Lat Krabang, that we would like to be global engineer. So this is some part of the environment and atmosphere. KMITL held so many years of the first or number one of the countries in industry income. That means we have many facilities that provide service and also innovation to earn more income for not just only for education from students. So this is number one rank in many programs. Some programs are the top one, especially this year. I need to have like congratulates for the Department of Mechanical Engineering as the number one of the country, being Thailand's number one university in the field of mechanical and aerospace engineering university, which is from research.com. So let's move in. The topic that I would like to show you today is include what? Introductions, talk about my laboratories and some of the related research work, problem formulation, and conduct some of methodology and experimental, simulation setup, because I will mainly focus to show you about numerical solution and results and discussion, and followed by conclusion and reference. So as the energy demand that we can notice now, we try to convert from from conventional engine to be electric power car. So that seems like we need more power to supply for any appliance, and especially for our life that need to have mobile phone and also other device, computer we need to use all day, all time, right? And also, how can we realize about what happened now for the earth? Because we notice that it's not warming, it's just boiling. So some of the area, especially in Thailand, we call global boiling according to its kind of hot weather that we can, cannot imagine as, wow, it's quite hot. So the plan for Thai government to have more renewable energy consumption, and also they would like to create any platform that can let us have carbon neutralization and reduce carbon dioxide is for everyone in the world. So humans need to realize and help each other, especially as engineer. We need to think and find some innovation that can save us as human facing with pandemics, with COVID-19, and followed by inflations that deal with economics decline. So how can we solve that problem? Because some people, some of GDP is gonna getting lower and lower. We need to think about some technology that just ordinary people can use and they can sustain their life. For example, renewable energy that I will mention today. So in Thailand, we have the global land to produce electricity in the country. The land is 134, and low carbon electricity is just only 13.5%. We hope that we can reduce some amount of CO and CO2 in the near future in order to save our earth and some of the climate better and change that we need to facing some of the ester and flooding and even the thunderstorm. Can you imagine? Some area might affect with power back out. So if we have power storage or energy that we can maintain to your house with free independent from grids or out of grids or distributed power system and combined heat and power system would be nice that we can create for each community. So install renewable energy capacity in Thailand. I think that every renewable types need to have more technology to develop them. For example, like solar energy breakthrough, right? So I hope that we can do something with biomass breakthrough as well, not just reliant on the combustion only, but for other type that we can have fields and use that for create power for us. For my lab, and you can notice this is the gear lab. I name this one is Green Energy Conversion Engine Research Center. So this part is show one of the big engine that I have two of them, but it's different heater type. But today I will focus on this kind of YouTube, the U shape of the heater tube. You can notice right here. And we have the fin. Annular fin is gonna be around the heater tube. As engineer, mechanical engineer, I think that you know about this. And this is solar dish that we can also convert from some of the dish like satellite dish. Like this one is 3 meters diameter. So that create high power enough to drive 2 horsepower stirring engine to pump some of the power for us. And if we consider about stirring engine, the advantage, not just only using for power only, but we can have heat pump as the cooling system. So the cooling system that we can save even vaccine because it can reduce the temperature or cool down to minus 200 degrees Celsius. So I aim that I can make another pathway that we can have stirring cryogenic that we can also produce any new version of air conditioner. But since I'm alone and I need to collaborate with my students and some of the colleagues that they can help with me, it seems like it's gonna be slow, gradually improve. But I'm so happy that now my lab can establish with this big one. Look at this. We have wood pellet hopper. And then we're gonna handling this one to the feed hopper for the gasifier. This one called updraft gasifier. This is the compact one and very nice and efficient to provide suitable heat for the stirring engine. So whenever we have syngas, we'll go to this way and then go to the burner. So the burner will combust this fuel gas or combustion gas for the stirring engine. And then the stirring engine is the external heat engine, will not provide any pollution from the engine, but we can control the combustion chamber to have very ultra low pollution. So this is very good way because if we can control it, that means we can decide and have a good combustion chamber for stirring engine, and stirring engine itself no pollution because the stirring engine is the closed seal and hermetic seal engine, no combustion inside. So just working gas expand and contraction and produce work according to piston move. So this is the stirring engine. And then we know that as the power system, we should have at least 2 sources of heat source. So we should dump some heat to the cooler like this. So this is cooling tower that I consider used for the stirring engine. And then we will have the coolant for cooling the system. So cool the air in order to contract the gas inside the stirring engine, and then we're gonna shuttle the gas to the heat zone or heater right here. So this is the most important thing. Whenever the heat can be absorbed and conduct, radiate, and pass through the heater tube, that means we can gain and accumulate some of the heat that can produce power and we can use with biomass. Let me show you right here. This is the engine part connect with the hot gas chamber or the combustion gas chamber. And we can call flue gas chamber. Why? Because if we direct burn to the materials we will have fatigue, and thermal fatigue will destroy that heater section. So we should save that power and also save some of the materials that we have for the blasting, because we have different piece. We have annular fin and then the heater tube. So we need to connect them with blasting or some kind of spatial welding. So that joint is very sensitive. If we have high temperature over 1000 degrees Celsius, so we shall not move with that or use with that level of temperature, even though we can make any materials to have like heater for us. But I consider use this one in order to have lifelong span for the stirring engine. To enhance the heat transfer, we will improve about the heater section, including number of the fin suitable one, and also how can we encourage some of the combustion gas or hot gas to circulate and try to, transfer between them, because we have outside of the heater tube is flue gas, and inside of the heater tube is working gas that we will use helium. And this is the U tube. So this is the U shape of the tube, and then we have annular fin around it. Optimized heat exchanger system. We divine and see some case. It's gonna come up with our design. So this is 6 case to study and examine about the thermal efficiency or the thermal effectiveness between them, and flow characteristics, including velocity and pressure drop influence on thermal conductivity or thermal heat transfer. So let's look here. This is another related research work in Denmark. They produced the huge one using updraft gasification system, and the sterling, the green one is right here. So the government's support for the renewable energy. So they have many type of sterling engine providing for many applications, can use in the hospital, can be used in the university and also hotel. So this is very nice one too. This consists of 4 engines with 140 kilowatts electric. And this is the plant efficiency, 88%, considered as the CHP. And the electrical efficiency is 17%. And this is what I just let you guys look at the heater section that they have. So the engine has the heater tube right here, and then they will connect with the chamber. So the hot gas will circulate around the heater tube right here. When you notice about their work, they have some section with fin and another section without fin. And the section without fin, they let the flue gas flow in this direction and then come this way by curving the shape of the profile of the burner right here. This is the profile chamber. So when you go back and notice, they will make some of the spot that will let the air flow in and try to guide flow of the hot gas. So governing equation is going to talk about, we will use some of ANSYS model to solve this one. So continuity equation, Navier-Stokes equation, energy equation, and some of momentum. So we need to find thermal enhancement factor. Thermal enhancement factor is the technical term that one of my colleagues, he is the top 1% of researcher who have cite of many publications of him. So this is the one that he showed about heat transfer enhancements. I had a chance to work with him, so this term is very impact. So we will compare between Nasa number with the design that we have and compare with the ordinary one or without any improvement. And that will relate with the friction factor very much. So the friction factor, it depends on pressure drop very much. So pressure drop and also the length, that the tube length is going to be influenced on the heat transfer as well. However, we include Nusselt number in terms of heat transfer coefficients right here with convective heat transfer coefficients H. This one is not the properties of the heat transfer, but depends on the heat transfer characteristics. So I will let you see right here as well. This is the heat chamber part. So contained with the air preheater in order to supply for the burner that will have more temperature from the combustion right here. So this is the inlet air that we will have fresh air from the rotary pump, and also some of the syngas, including of the preheat gas that we will supply right here. And the Stirling engine part is located right here. So they couple each other right here. So the part that I will look up to is going to be how to create and have more heat transfer. We will think about what is the influence factor, very, very high impact. We will look at fin tube. So this is fin tube, and then we will see some of the burner profiles and introduce the regulating plate or the guiding plate. So the guiding plate will play important roles to create the pressure distribution and also flow distribution along the section right here. So when you notice and observe, and you can notice how can I want, how would I, how can I like to have that flow pattern looks like this. So it's gonna flow from the hot combustion gas through this way. So this section is gonna be alumina tube, and then we're gonna flow of the high hot gas, high temperature gas, extremely high temperature gas, and then flow along this way in order to reduce some, and then we will let the heat go for the air preheater and some of heat that we can utilize for other session. And then we will let the combustion gas or the flue gas pass through this section and recirculate again and pass through this one. Like we draw letter S, and then we're gonna let the exhaust go through the pipe right here in order to preheat air in. So this is one of my research work that I introduced some of turbulator in order to create a heat combustion gas that can distribute very good stability flame right here in order to let it heat the temperature with stabilized flame, and then we will have heat distribute along the heater coil. That would be perfect, because if we have different or unstabilized according to of the solid fields that create some of stabilized easily, that means we will not heat consistency. So that's gonna make some of expansion of the tube differently. So not uniform expansion at and it can create some of the thermal heat and fatigue on the materials. So we need to realize about that because in terms of life service. And here is the heater coin when we see in front of them. And this is the annular fin. And then we will look at all the parameter. First, we will compare with the smooth tube and here with the fin tube. And then this is the case that we will look at and the dimension is right here. And this is the location that we will curve and profile the hot gas chamber or flue gas chamber. And this will be the heater tube that we can put and couple together. And here you can see this will be the circulation or the flow path of the flue gas. And this is the new design that we adjust with the combustion chamber profile and also the guiding vane here. So in order to introduce the baffle, protect the tube right here, not overheat, and also let more gas to circulate and let more gas to move and circulate consistency and uniform inside this heat chamber. So here is the design. And then we have dimension. So let's talk about the first case, the ordinary one without anything like smooth tube with ordinary chamber. And then here we increase fin for the heater tube. So this is the case 2. So case 2, uncurved wall and then fin tube heater, no guiding flow path. And the case number 3, we introduce the curved profile and then we will see what happened here. And we also introduce the baffle plate in order to guide for that movement or flow of the air, hot air here. So this is the horizontal guiding ring. And then this is the J shape that we have, like horizontal plate connect with the inclined one. And another one we call the U shape. So this is going to be inclined with opposite direction, connect with the horizontal plate. And then we will see, this is the case number 6. So what do you think about which case is going to be the best one? So when we need to use some of the software, we need to consider both thermal and flow. So fluid need to be taking account to this energy and mass transfer. So this is very important for us to select the software that can align and give us the nice solution. So I prefer ANSYS Fluent. So we will have this model. Cut some of the part because we need to match them. So the match number of size would be limited and it's quite time consuming to conduct simulation. So here I provide the conduction conditions right here. The fluid domain including 2 things. First, flue gas outside. And internal flow is going to be helium gas. And the mass flow rate of these. And the temperature of the flame is about 1000 Kelvin. It's approximately 700 degrees Celsius. And then we will look at any conditions that we will put to the model. So this is for the conditions here. And then this is the mesh size. Start from 1 millimeter to 25 millimeter. And then we have model validation in order to compare between the theory and simulation. And then we study that for the fin tube, number of fin tube very impact for the heat transfer a lot. If we look at the thermal enhancement factor, it can be improved 25% in case that we can fit some of fin much more. So this is 32 in the length that I have. And the heat transfer that enhanced from ordinary one, 157 to 197 watt kilo. This one is heat transfer in terms of watt. And this is when I introduce the guiding flow plate, is create more velocity flow inside. So, and how about the pressure drop? So it's along with the length of the tube, the higher velocity, pressure drop will be very high. And if compared with the introduced with the curve profile, please look, we have all the fin tube right here, but we have another curve profile that introduced right here. It seems like case number 3 is so bad because it's shortcut flow. So it will not circulate through this lesion. So this is no like blind spot lesion. And then when we introduce the guiding vein, and it will create more flow that can go to this location. However, we also introduce another J-type like here, connect with the incline one, so can let some flow go to this section and consistency. So you can notice that case number 5 and 6, very nice. And then when we let the flow of the hot gas or sea flow only, so the circulation of the flow here is not even for this one, because here is going to be some of the blind spot locate right here, and here creates some of turbulence inside and not good for heat transfer right here. So it's going to be blind spot right here. And then we would like to have this case number 3 and number 6 or number 5. However, this is quite not significant different. And then we will look at the heat transfer distribute along the helium. Supplies that the first case with ordinary one is the most temperature, the highest maximum temperature of the helium exit temperature. Just what? Because of the pressure drop play important role on that too. So that's gonna make some of the temperature cannot, raise a lot. But however, this many shortcut of the air as well. And this is the temperature distribute along any case. And from the thermal effectiveness that we can see, we can notice that the first case can play a nice role in the small velocity. However, if high velocity, this one is going to be good. So then we look at the pressure drop, this number, and then let's see some of the velocity of the hot gas. If we can have high velocity, high temperature will be increased, and also heat transfer more. So this is the case that I picked for this heat transfer in the laboratory. So this one is the one that I show in the extended abstract as well, about the circulation inside with velocity and pressure profile. And also this is the temperature distribution. This is eddy viscosity play important role in this flow. So in the conclusion, we can make conclusion that if we would like to come up with a new design, or we can have more design pattern that would be sold for the next one, just only use simulation and we can do it for real, or we will not manufacture without consideration before or simulation in order to see how can we augment or enhance heat transfer. For the Stirling engine can be improved with the heat transfer whenever we add more fin, and the number of the fin is impact in the heat transfer a lot, and also the efficiency of the system depending on the curve profile as well. Whenever you increase of some of the profile curve, you need to have more velocity of the hot gas in order to reduce some of the heat pressure drop on that part. So Thank you very much for your listening. So I would like to thank this work support by KMITL with the funding of research for the fundamental fund, and some reference are shown here. Thank you very much.
Thanks, Professor Sutapat. Any question from audience?
Yeah, so thanks for nice talk. So I have two questions little away from the core idea of the talk. So first thing, even with this 18% electrical efficiency, what is the case like why this Stirling engines that is still relevant?
Well, because of Stirling engine can apply with some of low grade field. But standalone, every system is such a small number of efficiency, even the steam power plant, you know that. So we should combine with some others.
And then in that updraft gasifier, you said like it is nicely really compact system. So what is the gas cleaning method? Some details can you share?
The detail of the gas cleaning?
Gas cleaning system before it goes to your combustor just before they start.
Okay, let me show you.
Any other question?
Very good questions too. The system here, we have some of the gas that will flow right here, right? And we have some filter. And then, we have some of the filter down below here in case of we have ash. But for burning here, we have some of the filter to go before the burner, definitely. So to design like this part is very important because we need to maximize the zinc gas. This is the technique that I have with my colleague. But he can produce the small and compact one. If we can build very small one, if compared with the power plant normally is gonna be huge one. And yeah, we have some filter and we clean some too. Pass through some of the steam, but I cannot show you. Yeah, thank you.
Thanks, everyone. And let us thank once again Professor Sutapat. Thank you.
We'd like to extend a heartfelt thanks to our keynote speaker for delivering such an inspiring and thought-provoking presentation. Your insights and expertise have greatly enriched our understanding, ma'am. We would also like to express a sincere gratitude to the session chair, Dr. Ritupurna Datta, for his exceptional efforts in conducting today's sessions. Your contributions have been invaluable to the success of the event, sir. Thank you.
Now I would like to request Dr. Ritupurna along with Dr. Umesh Kumar Bas to facilitate the keynote speaker, Professor Dr. Sutapal. Now I would request our coordinator, Dr. Umesh Kumar Bas, to felicitate our session chair, Professor Dr. Rituparna Datta.
we'd request our dignitaries to please be seated. We'd be starting with the second session shortly.
Good afternoon and a warm welcome to our distinguished guests, esteemed faculty members, teaching staff, and all students attending today. I, Mohammed Haider, with my colleague Parth, will be your host for this keynote talk. I would like to introduce the session chair for the keynote talk session, Dr. Ashok Kumar Singh, who is an associate professor at Department of Mechanical Engineering, Galgodia's College of Engineering and Technology, Greater Noida.
I would now like to request our session chair, Dr. Ashok Kumar Singh, along with our coordinator, Dr. Mayank Chawla, and faculty member, Dr. Mahendra, to present the Tulsi sapling to Mr. Amisha BS as a token of gratitude.
Today, our keynote speaker is Mr. Ramesha BS. The topic of his keynote talk is Power of Optimization for Smart Product Development. Mr. Ramesha is currently the head of academic initiatives at Altair India's Hyderabad branch office, overseeing operations for India and GCC countries. He holds an MTech in Advanced Manufacturing Engineering from NITK Suratkal and brings over 23 years of expertise in the CAE field since 2002. His career spans diverse roles including optimization, product design, technical support, business development, and pre-sales and post-sales technical support. He currently collaborates with incubators nationwide and supports startups through the Altair Startup Challenge. He also empowers faculty and institutions with Altair tools, bridging the gap between academia and industry. Previously, he has played a pivotal role in business development and technical support for major automotive OEMs, tier 1 suppliers, and engineering consultancies across southern India. Now, I would request our session chair to take over the session and ask the keynote speaker to deliver the keynote address.
Thank you, Mohammed. Thank you. Let me cover the intent of my presentation with the first slide. Okay. This talks about how the products have been evolved over a period of time and how the USPs are covered. You might have seen one of the famous two-wheeler sold in India, Bajaj Chetak. And if you see the what you called the unique selling point of this particular vehicle, if you go back 10-20 years, they talk about the CC rating, engine capacity, BHP in these lines, which are all more mechanical in nature, and maneuverability becomes key ingredient to it in terms of showing the video. But now the same Bajaj Chetak in the form of electric vehicle, okay, the unique selling point, you might have seen Amitabh Bachchan talking about the vehicle, where he talks about the what do you call over the air updates. You can locate the vehicle, Google Maps, okay, which are all IT enabled solutions. So in a typical way, you're making the product smarter and smarter because it can predict a lot of things. It can talk to infra. Okay, that means vehicle to infra communication is happening. And that is the intent behind my talk, which I'm going to cover in the coming slides. Now, the theme behind my presentation is optimization and smart product development. I will start with the concept design, how optimization is going to help you at the concept level and also at the design fine-tuning level, and take it to the multidisciplinary optimization where you can create a digital twin, that means CA-driven digital twin, and then the data-driven digital twin. So overall, this contributes to smart product development. Small introduction to Altair. Okay, I may have to skip this. There is no audio. So this is the vision of Altair. We work on computational intelligence, which will drive innovation for a more connected, safe, and sustainable future. Basic information about Alter. It's a public limited company, NASDAQ listed. We have presence in more than 28 countries with 17 offices. More than 3,000 employees work in Alter. And we provide solutions to some of the global trends, which includes additive manufacturing, autonomous driving, ADAS, big data, cloud computing, machine learning, manufacturing analytics, and many more. So in India, we have offices in 5 states. Okay, you have an office in Bangalore, Chennai, Hyderabad, Pune, and Delhi, and Bangalore being the headquarters for the entire APAC region. And of course, we have 16,000 plus customers globally, and you can see the span usage of Alter products across different verticals. The things which important to the student and faculty and academic community is this, where what is creating disruption in the market, right? So electrification is one thing where fossil fuel is being replaced by electric. Okay, you can see in electric vehicles. Companies moving towards AI-driven simulation, data-driven enterprise is happening. Semiconductor creating a buzz noise where a lot of funding is happening from the government. Fund flow is happening, and people are moving towards cloud in terms of capturing data and doing analytics on top of it. And of course, sustainability, where they want to have a less carbon footprint. So these are the areas where there's a massive disruption happening. At the same time, investment is flowing into India, and that's where you need to focus on. To help this, we have 3 platforms which help you to do the simulation for the smart part development. I don't want to go in detail about each product, but let me give the essence with one such technological disruption. For example, if I want to design and develop an electric vehicle, you have various requirements as per the homologation agencies. It could be ICAT or ARI. Okay, they talk about a lot of load cases that can be approved if you submit results through these. Mechanical, we talk about strength, stiffness, fatigue, durability, NVH, redundant handling, external aero. All these load cases can be simulated with the set of solutions. And of course, to design the motors, you can use our solutions, which is not only for electric motor design, but also for multi-physics, which talks about NVH and thermal properties also into consideration. And of course, next comes the battery thermal management, battery pack creation, and the digital motor control, those kind of stuff. At the same time, once you have a lot of sensors on the device, you track the data and you create a digital twin out of it, right? It's a data-driven digital twin. So you have one platform which can answer all these, which is the essence of our solutions on EV, which I want to showcase through this particular slide. At the same time, manufacturing is one of the key strength of Alter, where you can simulate forming, extrusion molding, 3D printing, those kind of manufacturing simulation capabilities through Alter products. Okay, now let us come to the key topic, optimization. So this is how a typical design process that we come across, where if we start with concepts, where CAD comes into picture, you can easily create CAD geometries out of it. And to verify the load cases, you do the CA simulation, okay, where CA tools comes into picture. And note that if you want to improve the design, you modify the CAD geometry and go back to the CA process to repeat the task, okay. So this is an iterative process, and this is what most of the people will try to do as a validation process. But Alter is professing about this in a different way in terms of CA driven process rather than a CAD driven process, where you need to use the CA upfront before CAD, so that you can derive the CAD geometry based on your performance requirement and take it to the CE process. And it is the most mature way of designing this particular process. And I can substantiate in detail. Please give importance to this. As the merger nature itself will give you a lot of inference about the optimization, right? Don't limit yourself when I say optimization with respect to only the mass reduction point of view. Okay, optimization is all about performance improvement, both at the concept level and also at the design fine-tuning level. And the CE comes into picture in between. So if you see the bamboo tree, okay, it is optimized by Mother Nature. It has highest torsional stiffness and rigidity. That's why it is used as a building block in constructing tents and houses. You have penguin which can maintain its drag and lift coefficient, can maneuver very easily inside water. Okay, Mother Nature is the optimizer. Our submarines cannot do that. Birds can fly in both low altitude as well as high altitude. The wings have been optimized like that. Honeycomb structure is a great example for your what you call composite, having higher specific modulus and specific strength. Okay. This is just an example how you can inspire from the nature. Okay, if you want to optimize certain things, either you have to do simulation technique or you can get inspiration from the Mother Nature. And you can see one of the airport from Stuttgart in Germany where the pillars look like a tree structure. It is inspired from Mother Nature tree. Okay. Now, why do you need optimization? Because you have more power at the right at the beginning. At the concept level itself, you can do optimization because your design freedom is very high, and that is the essence of this particular chart. There are various types of optimization which can be used at the concept level, which includes topology, free size, and topography optimization. And at the design fine-tuning level, means the first stage is all about creating concept, which acts as an input to your CAD process. Take this to the CAD process, create a manufacturable drawing, and take it to the CE process where you apply all the load cases, get the results, and if you want to fine-tune your design, then you go for parametric optimization. And that's where one of the tool called HyperStudy, which is being used by the industry for many years, okay, where you can do the mathematical part of it. Okay, that means digital twin part of it. Through simulation, you can create a meta model out of it, and it can answer all your multi-physics simulation because you can correlate to any of the physics. Okay, you can club with multiple simulation solvers to optimize the design. Okay, multi-physics, multi-dimensional. Okay, that's the intent behind this. For example, I want to change the parameters of one part by keeping CFD solutions into consideration, electromagnetic solutions into consideration, your NVH and durability targets into consideration. That means it's a multi-physics, right? So you can talk to multiple solvers at a time and you can solve the problem. It's a DOE technique, right? And that's where the strength of optimization comes into picture. And this is the essence which I want to make sure that this topology optimization is not for mass reduction. Okay, whenever you do analysis and any performance that you measure can be taken as a design constraint or objective function when you are doing optimization right at the beginning itself. So for various physics, okay, it could be fatigue, it could be NVH. You can set as a target for those optimization and get the distribution and take it to the CE simulation. That's the essence of this protocol. For example, one simple example I want to give you here, it's how to design a chair. You have design space and non-design space. Design space is some area where you go to sit on the chair and the entire below area it's filled with material. I put 4 constraints at the 4 corners and try to solve the problem. It gives you 4-legged design. Okay, but at the same time, if I put a circular constraint at the base, you get a 2-legged design. It's a different concept. And if I make my input, that means design space as like a hourglass, you get a 4-legged design but a different shape. The intent what I'm trying to convey over here is you play with this design to create different solutions for the same problem, same objectives. That is the advantage of optimization. At the same time, you can take one output, when one such best design into the realistic world. How do you materialize it? Okay, you can transform this material distribution into a 4-legged design, or you can go for a 2 bend tube structure in the second image, or you can go for a forged component. Okay, okay, that means the way you realize the material distribution depends upon the existing manufacturing capability, the cost, the material, and many aspects of this picture. Similarly, this is one example where I want to design a bridge. I don't know how the bridge looked like itself first. That's why I'll take a brick shaped material. Okay, you don't need a CAD input. That's what I mean to say here. It's a primitive. Okay, rectangle is a primitive building block. Anywhere you can create it. You fill with many elements and you make one strip of element as a non-design space where the movement of vehicle is going to happen. So I assume uniformly distributed load. 2 shores of the river, I will make it as a constraint at the base. And yellow region is where I am allowing the algorithm to remove the material. Okay, and you get a distribution over a period of iterations because it runs through iteration. You have basically a penalty factor to each element. So I am moving an element which is like a steel to a paper by playing the density. Eventually, I'm not reducing the density here, I'm putting a penalty factor here during the optimization process. So the contour that you see is nothing but a density plot where you're going to see high red region which indicates which has retained material, and the blue region is something which has lost the material. Okay, that means it has become a paper, almost like a zero density. So which indicates very clearly that which are the regions where you need to take into consideration critically and which are the regions you can eliminate directly, which helps you to do optimization to get optimal material distribution for the given boundary condition, not just limited to your structural, but also with respect to any physics that you simulate in our solutions. At the same time, you move the row to the bottom, again you get a different distribution, and you can see some of the bridges looks like this particular shape. Okay. Now, let us, okay, again I will skip this particular video. It's a video of students how they have derived drone structure with the help of optimization, and with the help of 3D printing they have printed it. So this is the stuff which is derived through OptiStrat, is our solver from Alt. At the same time, this is a case study from Boeing, where they have developed lightest bike, which is just 36 kg, and it can go up to 90 km per hour. It's electric bike. The entire frame is being optimized with the help of solver OptiStrat. So these are some of the relevant examples which I can share to the audience so that they can explore these solutions for various scenarios in your project work or again, let me move on. This is the example I gave about optimization at the concept level. But when you go to the CE, there are so many CE verticals comes into picture, right? You want to improve the performance respect to NVH, crash, durability, electromagnetics, and many more. And you need to identify which parameter is influential on the performance. And that is where the parameter screening comes into picture, which I am not covered in this particular slide, is called hyperstudy, where you can do the parameter screening, which is going to tell you which parameter is influential on the performance on various physics. So you can take only those parameters to optimization, okay, through screening technique, parameter screening technique. At the same time, this, since it's a completely a mathematical code, it can talk to any solver for that particular matter. Whether you have a solver, a B solver, a C solver of different physics, you can connect to them, understand the performance for each parameter. Basically, you just solve the problem at the lowermost bound or uppermost bound, typically sensitive analysis that we do. And you can check the slope of this particular curve. If there's a slope, it is influential. If there's no slope, it is not influential. Okay. And upon this, okay, you create a mathematical model out of it for optimization. Because many cases, what happens, your number of parameters influencing the performance is very high, and you can't do sampling for every cases, right? It becomes the infinite number of cases will be there for you. That is where the sampling comes into picture. Full factorial, fractional factorial, Latin hypercube, depending upon the type of linear non-in problems. There are some techniques out there which will going to help you in terms of sampling. Only at these parameter values we solve the problem and create a meta model out of it. Okay, it's an approximation. Okay, that's what the digital twin is all about, right? You create a meta model and predict certain things, and that's where the optimization is very helpful. This is about simulation-driven digital twin. At the same time, you have solved this particular problem. You already have a physical asset on the system, and various parameters you measure through sensors. That will give you a lot of insight about the performance, and you can correlate with the simulation-driven and the data-driven to create a pure digital twin to control the performance for preventive maintenance, fraud detection. Many applications are, and that is where the digital twin comes into picture. And to achieve this, okay, you need to go beyond your mechanical field, and you have to work on embedded system for embedded programming. You want to work on electromagnetics for under design. You want to work on data analytics. Okay, many more of this particular sort, and that's where I'm trying to cover certain aspects of high frequency electromagnetic analysis, where we talk about antenna design, antenna placement, radar cross section, EMI, EMC, again under high frequency electromagnetic analysis. And note that all these verticals are so integrated. It means it's a imperative for mechanical engineer to learn these domains for better product design purpose. Okay, you don't need to be an expert in this particular domain, but the importance of electromagnetics, embedded programming, all are relevant. Data science is relevant to mechanical engineers. At the same time, you have low frequency electromagnetic analysis for motor design, transformer design, okay, and for those kinds of requirements. And then comes embedded systems. Okay, of course, I'm not an expert over here, but typically I want to say there's a platform which is available for you to explore. Okay, kindly explore, which can help you for embedded programming in this area. Then comes the power electronics and the PCB design. The list is very high because I'm actually trying to endorse mechatronics for mechanical engineers. That's the need of the hour. Okay. And the last is data analytics, where Rapid Miner being the #1 platform for data science. The data that you get from the mechanical component, physical asset, you can create a digital twin out of it, and you can compare and calibrate with your simulation-driven data twin as well to control the devices. Okay, let me skip all this bigger part. So hope with these examples which I covered over a period of time, you can see the relevance of optimization plus the smart product development platform what Alta is offering, which is useful to you. So kindly explore these solutions, and at any point of time you have any queries, I'll be very happy to help you with this. So with this, I'm going to conclude my slides, and other slides are more on the data analytics part of it. Any questions, I'm very happy to take up.
Hello, sir. My name is Tejas Lele. I am from Koni Cranes. So I would like to ask you a question on the first part that you have noted that instead of going to the CAD first, we prefer to go to CAE. So can you please elaborate on that point?
Absolutely. So this way, I give an example about this. Okay, if you want to design a bridge for this particular example, I don't know how the bridge looks like itself. I take primitive as my input. Okay, I know the loading condition which needs to be bared by the final product. Right, you have vehicles moving on the bridge. Okay, that's why I will apply the uniformly distributed. I will make one strip of element as road, and how it is being supported, I don't know. That's why I put a 2 constraint to the brick. So the essence is I don't emulate my design with the existing design on the real world. Rather, I'll go with a primitive, give bulk material to the analysis to solve my problem, come up with a distribution. And distribution, you cannot directly manufacture it, right? It's only a distribution. That means load path for the material. This is an inspiration to the CAD to come up with a truss member, typically. Like this, there are so many examples, okay, I can give. This is the chair, right? So we have seen chair like 4-legged design, but you have also seen certain chairs with 2 legs and others. So in all these cases, I'm trying to play with the primitive, derive certain material distribution, satisfying my boundary conditions, okay? And these boundary conditions not just limited to structural world, could be any physics. Only for representation, I have taken a chair. This is dominantly a structural example. But if you go for some other part like NVH, okay, bonnet is there, it is more prone to vibrations. Okay, you want to come up with a pro. In those cases, you have to go for a sheet metal topography optimization. Okay, you have to add bead pattern without adding mass to it. It can improve the stiffness to those kind of parts. So these are the relevant examples where you can play and understand the importance of optimization right at the beginning. So if you directly go to CAD, the problem is you will end up with a lot of iterations. It will waste your time. That's the part of it. And these are already used by industry now. But the best part which I'm trying to convey is the CA-driven digital twin and the data-driven digital, where hyperstudy is a predominant player, which Alta is professing for more than 25 years, which is used by the industry. I can hear.
So how you are like iterating those type of structures to analyze those?
It is done by the solver itself.
Okay.
By default, it uses density approach. Okay, it's apply a penalty factor to each element. I can share the case study technical paper presented by one of the Japanese author, which is being commercialized. Okay, so I can share it to you. It talks about the density method, how it is being used, how the penalty factor is weighed from each iteration, and take it to the final distribution of it.
This is software itself generates.
Yes.
Okay,
Software
nice.
itself it generates,
Okay,
and there are so many advanced features which you can create final CAD drawing directly from this. You can do casting simulation and many things.
okay, so thank you. Thank you so much.
Perfect. Thank you. Thank you so much.
Thank you, sir. We'd like to extend our heartfelt thanks to Mr. Ramesha for delivering such an inspiring and thought-provoking presentation. We'd also like to express a sincere gratitude to the session chair, Dr. Ashok Kumar, for his exceptional efforts in conducting today's session.
I would request Dr. Ashok Kumar, along with our coordinator, Dr. Mayank Shabra, to felicitate our keynote speaker, Dr. Kishore Kumar. Dr. Mr. Ramesh. I would request everyone to move to. I would like to request Dr. Mayank Shabra to facilitate our session chair, Dr. Ashok Kumar Singh.
I request all the dignitaries to please move to the E2 auditorium for the technical poster presentation. Thank you.